Good afternoon, ladies and gentlemen. Welcome to Math 30-2, Chapter 3, Section 1, Exploring Probability, Part 2. Now, we just did the dice differences handout. Now, before we go on, I have to talk about a fair game. A game in which all the players are equally likely to win. For example, tossing a coin to get heads or tails is a fair game. Okay? Because you can get heads or tails. A game where everybody's equally likely to win. Now be careful. Notice the joke here. I don't mind spiders. No, really I don't. However, if they enter my house, they are more than fair game. If they enter my house, they die. So fair game means more than one thing. But we're talking about a game where all players are equally likely to win. So, we now have an experimental probability handout I'd like to try. We'll call it exploring probability. Now, you need two people to do this. If you're at home, find somebody to help out. Well, you don't actually need it, but it's a lot easier. Brother, sister, parent, aunt, uncle, grandma. Now, what you're going to need are slips of paper and two containers. Okay? So 2 buckets, 2 bowls, a couple of cereal bowls. Now, remember, fair game. A game in which all the players are equally likely to win. For example, tossing a coin to get heads or tails is fair. Now, here. Sasha and Micah have to invent a fair game for a class project. Sasha suggests this game. 2 people play. Each player is a container. Both players put 3 identical slips of paper, numbered 1, 2, and 3, into their container. For each turn, both players draw 1 slip of paper from the container. Player 1 scores a point if the product of the 2 numbers drawn is less than their sum. Player 2 scores a point if the product of the 2 numbers drawn is greater than their sum. Okay, now, less and greater than their sum. Neither player gets a point if the product and sum are equal. After each turn, the players return the slips of paper to the container. So, everybody draws a piece of paper, compare the numbers. Look at the product and the sum. Remember, product, you multiply, sum, you add. So the big question here, is Sasha's game a fair game? Well, what I want you to do, set this up and play it for a few times. Okay? And record your results. I don't care who's player 1, who's player 2. But play it a few times and come back and we'll talk about it, okay? Okay, I'm assuming you've played it a few times. Now, who won? Player 1 or player 2? It's a very interesting question because in theory, I can tell who's going to win. So, let me show you. Let's look at the results. Now, remember, we just did this for the dice differences back here. Look at the possible outcomes. So we do the same thing for here. So, player number 1. This is player 1. We get a 1, 2, 0, 1, 2, isn't it? 1, 2, 3, sorry. Apologize, getting old, I couldn't remember. And then we have 2. 1, 2, 3. All right. So let's look at, and now remember the rules. Okay. Player 1 scores a point if the product of the 2 numbers drawn is less than their sum. Player 2 scores a point if the product of the 2 numbers drawn is greater than their sum. So, the product here, 1 times 1 is 1, 1 is 2, 1 times 3 is 3, 2, 4, 6, 3, 6, 9. Okay? So that's the product. And then let's look at the sum. 1 plus 1 is 2. 2 plus 1 is 3, 3 plus 1 is 4, 2 plus 1 is 2, 2 plus 2 is 4. Oh, sorry, no, this 2 plus 1 is 3. I know, I can hear you screaming at me, never mind. 2 plus 2 is 5. 3 plus 1 is 4, 3 plus 2 is 5, 3 plus 3 is 6. Alright. Now, did I make any mistakes? No, I don't think so. So the question is, who wins? Well, player 1 scores a point if the product is less than the sum. So player 1 wins where? When the product is less than the sum. There, 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 there. Five places. As I see it, player 1 wins 1, 2, 3, 4, 5. Five out of 9 times. Okay, just double checking my math because dumb things happen. And then player 2 wins when the product is greater than the sum. So that's here, here, and here. Player 2 wins 3 out of 9 times. Wins here, here, here. And then we have one tie, where nobody wins. Okay. The winner is 1 out of 9. Now, this is 9 out of 9. Just double checking. Yes. So, the question is Sasha's game a fair game? No. Player 1 will win more often. Now, if you only play this 2 or 3 times, you might not notice that. But if you play this like 30 or 40 or 50 times, you will clearly see player 1 wins more often. Unless you make it down that boo-boo like I do, which happens. So, some questions for you guys. Is playing Sasha's game once a good way to decide if it's fair? We got to think about that. But just play it once. Does that tell you if it's fair or not? No. Now, Micah says that, oh sorry, you have to explain why. I'm not going to explain that because this you have to hand in for points. I want you to think about it. Notice I keep saying once. Once. Micah says, number 2, sorry. Micah says that you can use theoretical probability to determine if the game is fair. Do you agree? Well, I'm going to stress right here. This is theoretical. In theory, player 1 wins 5 out of every 9 games. In theory. If you play 9 games, will player 1 win exactly 5 times? Probably not. Life is too random for that. Now, you can explain why and why not you agree with that. And that leads to the third question. When you play Sasha's game, would you rather be player 1 or player 2? And explain why. Okay? Now, I'm going to stop the recording here. I want you guys to finish this handout, and then we will continue on with the rest of the notes.